Once we get to where we stopped at last time, let me know and I'll slow down a little bit. Measures of central tendency. Again, all measures of central tendency are numbers that fall in the middle of the data. We're going to figure out or do some stuff with mean, median, mode of a population and of a sample. Find the weighted mean and the mean of a frequency distribution. Again, with the weighted mean, not going to put a whole lot on that, but frequency distribution, you do need to be able to find the mean of that. It's a little tougher because you got classes, you don't have each piece of data separately. Symmetric, uniform, skewed left, skewed right, and how different things affect each other. We'll talk about all that. Measure central tendency, we talked last time about mean, median, and mode. Those are the three most common. Mean, again, this says average, it shouldn't say average. It should say the arithmetic. Probably spelled that wrong. Yeah, wait, wrong. Well, I didn't become an English teacher. So it's the arithmetic average, sum of all the data divided by how many of them there are. Sigma notation, remember that's just when you're adding everything up. That E there, that E looking thing, that's the sigma. Two real important things, I think we said this last time. Mu, it's a Greek letter. That stands for the mean of the population. X bar stands for the mean of the sample. Two completely different things. You got to know when you're using one, when you're using the other, and know the difference in them. When you find the mean, we talked about this, always round off to one more place than what you started with. And if all the numbers were all whole numbers, then go out to the tenths and so on and so on. Nothing really hard about that. It says only round when you get your final answer. You can do that if you do everything on your calculator, but otherwise, sometimes it's sort of difficult. This example, prices for a sample round trip flights to Chicago to Cancun are listed. What's the mean price? All we're going to do, add them all up. Remember, that means sum, so we add them all up, get 3,695. Then you divide by, there were 7 of them, so you divide by 7. That's the mean. This one went out one decimal place. We might put another one on there because we know this is dealing with money. And then our money system, it's always got 2 numbers behind the decimal. So the mean price is 527, and as we did this last time, it's 527, and that ends up being a little high compared to the rest of them. How come it ends up being a little high? Those two sort of pull it up, right? And that's what happens with the mean. When you have outliers, it makes the mean either go a little higher than it probably should be or a little lower than it should be. Median, the middle number, so you got to put them all in order first. They have to be ordered, which makes it hard if you have a big long list, but on your calculators, if we have some big long list and you put them all in a list on your calculator, you can hit a couple of buttons and it'll put them in order for you. So that's something that we'll do as we go through some of this. It'll also, without even putting them in order, it'll tell you what the median is. So it puts them in order without actually showing you that it did it. Measures the center and ordered data. If you there's 2 different things that could happen. If you have an odd number, like we had in that first one, then you just count. And again, a lot of you, I've seen students doing this. All right, 1 on this end, 1 on that end, 1 on this end, 1 on that end, and just counting down as you go through on the ends, and then finding the middle one. That's fine if you do that. I usually just count how many of them there are, divide that by 2. And if you have something like 19, and I know 19 divided by 2 is 9 point something. Well, that tells me there's 9 on one end, 9 on the other end, and the one that's left over is going to be in the middle. If you have an even number, then when you get to the middle here, there's going to be 2 numbers in here. You're going to take those 2 numbers, add them together, and divide by 2. That'll give you the median. This one, we put this one in order last time. Just got them in order there. We got 1 here, 1 there, 1 here, 1 there, 1 here, 1 there. So that's going to be our median. We got rid of one of those numbers, put them in order again. So now we got 3 here, 3 here, so there is no middle number. We take those 2, add them together, and divide that answer by 2 to get the median. So the median for this one was 412. What was the median for the other one? Previous. Go back far enough there. There we go. 427. So 527 was the mean, 427 was the median. Quit putting bullshit in these. The mode's the one that occurs the most, the one with the most frequency. We talked about it last time. You could be bimodal, that's where you have 2 modes, so those 2 numbers both occur the same amount of times. Again, just to go back real quick, some books will say if you have more than 1 mode, then you don't have any mode. All right, so I'll accept it if there's 2 or more numbers. If you write down all those numbers that appear 4 times or 5 times, whatever the most is, I'll probably accept it as the mode, but you got to be careful because, again, some books or some math people say, no, if there's not one certain mode, then nothing else matters. There is no mode. So on this, if we look at this, we put them in order. The mode this time, 397. We talked about this one last time. When you're given a frequency distribution chart here and you're trying to find the mode, you just want whatever occurs the most. Well, the most was the Republicans. It's that simple. Comparing the mean, median, and mode. This is probably the hardest thing. Just don't always think that the mean is the best average. That's not always the case. A lot of students get into that. Mean is affected by outliers. If there's any outliers, then it really screws with the mean. Median, not affected by outliers, but it's only the number that happens to fall in the middle. Might not be the best thing to represent the data, but it could be. And the mode, the one that occurs the most, might be the best thing to represent data, might not be. It just depends on what all is going on. If we have some big long list, if we have some big long list like that and we go through and we find the median and we find the mean and we find the mode, maybe this 9, because it repeats over and over and over again, maybe that is the best to represent that set of data. Just depending on what the data is dealing with. Shape of your data and the existence of outliers may help you choose the best average. I think we're getting close, aren't we?
We have these.
Yes.
So again, symmetric, and I'm gonna add one to this so that we can just put it on here. Symmetric looks like this. With symmetric, the mean, median, and mode are all right there at one location. They're all the same thing. Symmetric, if we were doing a bar graph, I'm gonna add actually a few to this. If we made a histogram or a bar graph for symmetric, it would look like this. If I could draw one. So that's symmetric, something like that, where it just has that curve to it. For this one, a bar graph or a histogram would look something like this. Where it's got that tail going down to the left. For this one, a bar graph or a histogram would look something like this. Where it's got that tail going down to the right. And then the one other one that I want to add to this. Sometimes you'll have a graph that might look like this. Now all I gotta do is remember what it's called. Do you remember? I don't remember either.
I don't remember how to pronounce that one word.
What is it? So we'll get to that here in a second, but those are the four kinds of graphs that we're gonna, or four kinds of shapes that we're gonna be dealing with most of the time. I'll remember that here in just a second, as soon as I, let's see, we got symmetric, we got left-tailed, right-tailed. Looking at this set of data, it says find the mean, median, and mode of the sample ages of class. Which measure of central tendency best describes a typical entry of this data? Are there any outliers? Just look at the data.
Yeah.
Are there any outliers? 65. So when we look at the average age here, and we're not actually gonna figure it up, I'll let the slideshow do it here in a second. But when we look at the average age, what's that 65 gonna do to the mean? It's gonna make it higher, all right? So it's gonna make the mean a little higher. So probably the mean might not be the best way to look at it, because you got that one old person in this class with all those other people. Give me a number, just looking at that set of data, give me a number that you think would best represent the age of that class.
22.
22, maybe 21, somewhere in there, right? 21, 22. If they ask you, hey, the typical person in this class is how old? 21, 22, somewhere around there. All right?
Early to mid-20s.
How about early 20s? Where do you see mid at? I guess
24.
24. There's only two of them.
Yeah, but early
There's
to
one
mid. That covers almost everybody.
But then you're not actually describing anything. You're not. So then you're not telling Michael anything. You're just giving him some. Really? What's that mean? It doesn't really mean anything. So if we do this, we find the mean. We add them all up. The mean's about 23.8, almost 24 years. The median, 21.5. The mode, the one that occurs the most, is 20. Which one of those would best represent this set of data? We just said it. Which one? Probably the median. We said 21, 22. We said something around there, right? Well, that'd probably be the median. So this time the median would be the one that best describes the age of a typical person in that class. The mean was raised because of the 65, the outlier. The mode, there was just a whole bunch of 20-year-olds in that class, but they were the youngest ones, right? So that wasn't really a good thing. Here's a histogram of all that data. And you notice, you got this big gap here. So you got that big gap. That tells you that that person right there is a what? An outlier. Oh, got it right. A weighted mean. Weighted mean. I'll put this up here so you can. I went too far. Write this down. Talking about a weighted mean. Again, we won't do a whole lot with a weighted mean, but we will do quite a bit with the finding the mean of frequency distribution. What's that thing out in front of the formula here? Anybody remember what it stands for? Close. Sample part's right. Sample mean. So it's the mean of the sample. What's the other one then? What's the mean of a population? X bar, what's it? It's a mu. Come on, Brayden, you were supposed to remember that.
Mu.
It's mu. So on this, if we're doing this, and I think I have a slide on here that we'll get to here in a second, and we'll probably just skip over it because I'm getting ready to do it right now. My grades in this class are a weighted mean, all right? So what happens here is each time you take a test, it counts as 70% of your grade. The homework counts as 30% of your grade. So all this is saying is you take each item, whatever it is, a test or a homework, and you multiply it by its weight. So if you do a homework today and it's worth 10 points, then we take 10 times 0.30. Then we add that to, let's say we take a quiz next time, so that's a test grade, and it's worth 7 points. Then you take 7 times 0.70. So on, and you just keep adding up all of those things. And then once you're done, you're going to divide it by all of the weights added together. Well, in this class, all the weights added together is going to be how much? 100%. Or if we're changing it to a decimal, just 1. All right? Again, we're not going to do a whole lot with that. Main thing here, make sure you know that that's X bar. That's the sum. So we're taking all of these and summing them up. You guys get lucky because it used to be
Wait,
this
what's that E thing?
sum. So that means you just, whatever it says back here, like if it says X, you take all your X's and add them all up. Used to be in this chapter, and I quit doing it over the last few years just because I got lazy. In this chapter, all this stuff, and I know my son's school, they still do it out longhand, but I just use the calculators now. They give you, you have to do X, then you gotta find something else, something else, something else, something else. And this chart, instead of just being 5 or 6 like some of the charts that we've done, ends up being 10 or 12. And there's a whole lot more math involved in some of these other columns. And we'll do some of it, but we won't do it all. We'll do a lot of it on the calculator. You're taking a class in which your grade is determined from 5 sources, 50% from your test mean, 15% from your midterm grade, 20% from your final exam, 10% from your computer lab, 5% from your homework, Your scores are 86, and they give all the scores there. You can read them if you want. If the minimum average for an A is 90, did you get an A? So all we're going to do here, we take each one of these. We got our test score was at 86. Well, it said test count 50%. So we multiply that. Next one, the midterm, was 15%. So we multiply that, so on, all the way through here. The homework, we got 100 on it. Multiply that. And this is the way these grades work out. Look how many points you get for the homework, even though you got 100. And then look how many points you get for the test. All right, so the tests count a lot more. Then we add them all up. We get 88.6. And again, we're going to divide by the total, which is just 100% or 1. And what's our grade going to be? Did we get an A?
No, we didn't.
Didn't get an A. All right, so maybe an 89, but we didn't get an A. This is just, like I said, this is for my class. So what we would do in here, if you wanted to figure out your grade, just add all these up and times it by the 30%. Add all these up and times it by the 70%. Then those two answers, add them, and that's going to give you your average or your grade. Mean of a frequency distribution. I'll give you a minute to write this down. This is important. This we will do. Weighted means, I'm not real big on the weighted means. If you got a weighted mean, you're probably going to be sticking it into a computer somewhere or something. He was lying when he said that,
What did he say?
I think. So Riley must be one of them that her folks get her on that.
Yes.
He said, I think. And he said something else, but I didn't hear the rest of it. But I quit listening.
It's like when you ask your parents for something, they say maybe. Never really tell me.
Or it's like, hey, what's for supper? Or like it's, I don't know. And then they're like, who's asking? I'm like, I'm hungry. And they're like, nice to meet you. And they're like, Dad. I'm like, oh my God.
Dad joke. You make dad jokes?
But every parent does that. It's like the same ones. Nice to meet you. And they're like, shut up.
So mean of a frequency distribution. With the frequency distribution, just look at this. I'm going to make up one here. Just something real quick. We got our classes, then we got our frequency. Just a really easy one. So let's say we go like 0 to 2, 3, to 5, 6 to 8, and 9 to 11. So if that's our frequency distribution, here we got 5, here we got 2, here we got 3, here we got 6. I don't know, just making up numbers. All you're going to do with this, don't make this harder than it is. You're going to find the midpoint. That's what, where does it say? Where X and F are the midpoints and frequencies. So you're going to find X, which is the midpoint of each of these. Because you can't find, you don't know each number separately, so you can't just add them all up. So you find the midpoint of each class, and you take that midpoint, whatever it is, here the midpoint would be 1, here the midpoint would be 4, here it's 7, here it's 10. You take that midpoint times the frequency. So what you're saying is, in this class right here, there was 5 items. We're saying all 5 of those items were 1s. Because we don't know actually what each one was, because we didn't have the whole list. All right? So all you got to know is that's where it's coming from. So here we're saying that we have 2 4s. Here we have 3 7s. Here we have 6 10s. I'm not writing all 6 10s. All right? And what we're doing is adding all those up. Now, are those the real numbers that were the data set? Probably not. All right? All these numbers in this set probably weren't just ones. There was probably 0s and 2s and everything else. But we can use that to find the mean. So we take all of those, we take each midpoint, and we times it by how many of them there were in that class, and we add all of those up, and then we divide by this total, however many total there was in the whole group. That gives us the mean of the frequency distribution. Nothing really hard about it. If Lily wanted, could she go through and find the mean and write all these numbers out and add them all up? And then divide by how many of them there are? Yeah. All right, but you really don't have to do that. You just multiply this number times that, this number times that, this number times that, this number times that. Add all those up, and you can probably do that on your calculator. If I was doing this on my calculator, I'd punch in 5 times 1 plus 2 times 4 plus 3 times 7 plus 6 times 10, and that's going to give me the sum of all of them. Then I hit equals, then I hit divided by, what is it, 7, 10, 16, divided by 16. That gives me the mean of that frequency distribution chart. So all you do to do this, get all this up here. And I wouldn't write all this down. What I just explained is find the midpoint of each one, take each midpoint times how many there are in that class, add all those sums up, then divide by how many of them there were in the set. So if we were doing this one, we're going to multiply this number times that, this number times that, this number times that, this number times that, all the way down through here. And then once we have all those answers, we're going to add them all up. And then we're going to divide by whatever this total frequency is, which it looks like 16, 29, 37, 48, looks like 50. So we're going to divide by 50. You're amazed, aren't you, Michael, that I could add that up in my head that quick?
No.
Get it right. You're not?
I always think when like you're adding or something, how does he do it? But then I realize it's actually kind of easy.
Yeah, it's not hard. And what you should do, which I didn't do that time, when you're adding stuff like this, find stuff that go together easy. Like give me, what's 2 numbers here that go together pretty well? How come 2 and 8?
10.
Because they make 10.
And you have 20.
So then I got 10, then I got 20, then I probably picked the biggest one, which is like 33, and and third, and then I just start 39.
Or you could do
44,
6 and
50.
5, that's easy to just learn. So you-
Yeah, but then 11 might be hard to add to another
That's only
number.
one more than 10.
That's true.
44 minutes.
So about 41.8 minutes is the average of all this. Symmetric distribution, we sort of talked about this. This is what symmetric looks like. Now we'll remember the one I can't remember. Still bothers me. I'm going to try to remember it before I
Remember it.
get to it. Symmetric, skewed left, skewed right. Skewed left, skewed right.
You go.
Sorry, I should have told you guys this. I probably wouldn't have wrote all this down. The main thing is, know that that graph is symmetric. So if you see something like that, we call it symmetric. How come it's called symmetric?
Because everything in line.
If I do this, if I cut it right there, what's true about these two sides?
They're the same.
They're the same, they fold and overlap. Now with this, do they have to be perfect?
No.
No, because we're not ever gonna get anything in real life that's exactly perfect.
Are you getting a sub when you're out? Are you gonna get a sub when you're out?
Yeah, there'll be somebody here, I don't know. I'm hoping they can get a sub that just stays here the whole time. So that you guys don't have to mess with a bunch of different people.
Yeah, because it would have to be in class. In class lists.
Uniform, dang on. I was hoping it was the last one, so I'd have more time to think about it. If it's uniform, it just goes straight across, everything's exactly the same or close to the same. Again, it doesn't have to be exactly. Here I put symmetric on here because if it's uniform, is it still symmetric?
No.
Yeah.
If we cut it right there, are the two sides still exactly the same? Yeah, so it could still be symmetric. So if you see a uniform graph and you're like me and can't remember the name, and you put symmetric, I probably shouldn't mark it wrong. Doesn't mean I won't, but I probably shouldn't because it is symmetric.
Would you fix it if you came up?
Yeah, probably. If you came up and said, hey, this is symmetric, if I cut it right here. So if you could explain that to me, yeah, I'd probably say, all right. Now with uniform, think a whole lot of stuff in the world actually looks that way?
No.
No, not really. Some toilet paper right there would be easier on your nose. Don't smack Lily as you walk by.
I know it's hard not to.
That's why I stay up here.
Yeah. Thank you, I appreciate it. I thought for sure you were gonna say
Oh, yeah. I was walking by. I was going to it. Okay. looks sweet. I don't know what we use for freaking purple. Mine doesn't either, anymore. I want red and purple. I mean, it looks good.
Red and purple? I just thought pretty good with purple. It's like bigger.
I don't know what it is. The paint.
It's not like absorbent.
It's like a
The other two, again,
I'm trying to find more.
skewed left. Again, all that really matters is you know what the curve is. So it's skewed left because it's got that tail sort of coming out to the left. We're not gonna, if you get into statistics and stuff real deep, we're not gonna do it in here. Then you would worry about stuff, all right, the mean is to the left of the median and what's that tell us and all this other stuff. We're not gonna get into that much detail throughout this whole class. Could also be called negatively skewed just because it's to the left. So skewed right, which is on the next slide, could be called positively skewed. So if I know what elongate means, big words and stretches it out. Nothing really difficult. Skewed right, positively skewed. Again, look at it and got a tail off to the right. Was your dad crying last night at the start of the game?
The Bengals? Yeah.
Man.
I turned it and went to sleep.
Same. After they went down 14-0, I was like, there's no point we can watch this no more.
I waited for a little while after they went down 14-0, but then when they started driving on them again, I thought it's going to be 21-0 here real soon. I don't know what happened, but they were
They
driving.
stopped them.
Urban Meyer went for it like on 4th and goal when they did.
Is that what it was?
Yeah.
And they went like the halftime or whatever.
I
But
don't
what
even
blew
mind
my
this.
mind was we drive on it the first time, then we stopped that whole offense.
Yeah.
Let's start like throwing little screens and running the ball instead of throwing the ball downfield, which worked.
Yeah.
Then we did the second half when we came out, we scored easy. So we could have been
Yeah,
up.
your line did actually really good. Well, I mean, it's Jacksonville, but the line did really good. I like the 49ers, but I was watching.
They didn't look good the first half.
I mean, the Bengals line is like, they've upgraded their line, but it's still like, once you get against like the Rams or something, or once you get against Baltimore or
I
Cleveland.
don't think Zach Taylor's a good coach.
He's horrible.
We can't seem to hire a good coach.
I didn't think
Any
it was
Cincinnati sport.
Yeah, David Bell's horrible.
It's terrible.
I didn't think your last. Who was the last coach? What was his name? For Cincinnati Bengals.
Marvin.
I don't think he was horrible.
there forever.
He wasn't horrible, but he just wasn't.
Better than Zach Taylor.
That's
He could have won a playoff game.
Yeah.
just
But I think
couldn't
he
do.
could.
He was too much of a player's coach.
I think he could have did
At
good.
some
with-
point, you gotta put some foot on behinds and
You
say,
gotta make somebody mad.
I think he
get out there and do your freaking job or go away.
I think he could have did good with this group.
Yeah, that might be with
Yeah, I
some
think
younger people,
yeah,
maybe.
I think he could have done good. He's always had the older guys.
Summary. So find the mean, so on, all that stuff. We did all that. I'm not gonna go through that summary. That's the assignment. Again, write this down. Next week when you come in, probably have a chance to finish it up. Make sure it gets into the correct tray. The other stuff will be up there. Plus, I'll send you an email with video and everything on it. If you write this down here for a few minutes, we'll get calculators out, and I'll show you a couple things. Do me a favor and grab one of those, and I'll show you how to, next week, a couple of the things that we're going to do. with the calculator so that you know how to do it, so that you don't get, so you're not lost on Thursday. Jenna, are these dead?
Oh, yeah.
You'll leave your trash on.
Give me one faster. Thanks for that shit. Need some grease, bro?
Sorry, I'm gonna trade you.
Should we use the restroom?
Prettier.
I got plenty of pictures, man. Got greasy
That's
stuff.
all about the world. I probably couldn't see him anyway.
In the locker room and get it.
Hope that was a little better.
Little JP, get yourself.
You want 6?
No. Fine. Singular.